I recently spoke about Max Schwager and his work on understanding AI models. I want to double click on this again because I think his work is really important. It's one of those rare scientists who does important work and also has the ability to explain in a very concise and clear way what he's doing. So I think it's very valuable. His research is very valuable. The key question Schwager is asking is, do AI models generalize or do they memorize? And his answer is they memorize. Now, to me, this has three massive implications. Number one, I think Schwager's just coming at this from a different angle, confirming the bitter lesson. Second, it's obviously opening up the question, okay, if we want generality, first we have to define what it actually is, and then we have to train our models to actually be general. In other words, if we don't train our models to be general, they won't be general. They won't just be general because somehow the magic soup makes them general. And I think third, this is my, my view of the thing, is that we should look at AI not just from a model perspective, but include the company that is actually providing the AI. In other words, we should look at the full stack, including the people. Right now, it's people. Maybe in the future, it'll be agents. But right now, the biological intelligence, which is applying artificial intelligence. And one example is Tesla here, because you could argue that the Tesla FSD is just memorizing, but then the organization around this, in other words, the company itself is working actively as a general tool to make the AI more general by, let's say, applying shadow mode, by having a data pipeline, by using simulation and things like that to actually maybe memorize a lot more scenarios and that way be more general. I guess what I'm saying, at the limit, once everything is said and done, memorization and generalization converge to the same thing, which is in any kind of situation you can do the most optimal thing. Whether that comes from memorization or whether that comes from some sort of general tool. Again, we have to define what generality even means, and actually Schwager does that, which is amazing. Unless we do that, we just don't know exactly what we're talking about. So this is the Not Even Wrong podcast. It's May 27, 2026. This is Krim Delco. For the year, we're up 2%. The market is up 9%. We're underperforming by 7%. In the market, I think we discussed one of the biggest themes in the market right now for us is the neo cloud and how we position ourselves in the neo cloud. It looks like NVIDIA is losing market share in the neo cloud, definitely losing share in stock performance terms. And that's something we need to address as a fund. We've spoken about this, and we decided to stick with NVIDIA and not reposition ourselves because we believe that some of the neo cloud bottlenecks, which are now driving up the stocks, eventually will turn out to be an opportunity for NVIDIA. As far as Tesla is concerned, the robotaxi rollout is the main driver. There's a couple of other catalysts, SpaceX IPO and car sales, that are all also positive tailwinds. Now let's talk about this particular episode. So Max Schwager is a Stanford professor, and his main work is actually understanding AI models. So he's researching the models. So he's not building models himself. He's trying to understand what's out there, right? Or maybe a less flattering way to say it is he's looking at other people's work and trying to understand what they're doing. Now, that in itself might sound a bit demeaning, but it's actually incredibly important. And I think people like maybe, physical intelligence, the people on Sergey and Chelsea Finn, I'm sure they really appreciate this work because it's good to have if you will, they're the actor and Schwager is the critic here, and that's really very valuable. So the main question that Max Schwager is asking is, when a robot is cleaning your apartment or putting stuff in bins or whatever robots are doing, humanoid robots that we put out in the wild, and we consider them general intelligent. So it's not like a Fanuc robot that just does the same thing all the time. So we think, well, wow, this is amazing. You know, they're well, take the FSD. Okay, the car drives itself through San Francisco, Palo Alto, Austin, Texas, San Antonio, Texas. I mean, I've driven all of these places with FSD in the last 6 months. So this is, wow, this is general, right? Well, Schwager is saying not so fast. If we analyze the actual model, if we go into the guts of the model, we realize that what the model's doing is just memorizing action chunks. So it's all memorization. And that's why, and this is the first point I want to make, Schwager's work actually confirms the bitter lesson. The more data, the more memorization, the better the model. I think he would agree with me on that one. And I don't want to discuss the bitter lesson more. I think that's for other venues and episodes. The point is just more data, more general, and more general models and more general data. He actually shows in one of his research papers, he makes the point that a large model with more data is more efficient than a small model with more data, or a small model with small data, which kind of, by now we would say, yeah, that's a duh. Now, of course, there's data recipe, there's data curation. Let's not forget that. So the quality of the data matters too. But I think we here at Orange Capital Partners, we're in tune with the bitter lesson. The less human intervention, the less curation, and the more general data is, the better. I think that's what he's saying. And another way to formulate the bitter lesson would just be, well, just memorize as much as you can. And if you look at, I don't know, look at human intelligence. Let's say we put our kids in school and then they pass the SAT. What is the SAT? It's an intelligence test. But quite frankly, I haven't done it myself. I grew up in Switzerland. I've done something similar when I went to grad school, but not the SAT. What we really do is just practice, practice, practice. In other words, memorize, memorize, memorize. Now we don't memorize facts. We really memorize action chunks, whether those action chunks are thought processes or actual action chunks. If you train jiu-jitsu, right? You train jiu-jitsu. What is every coach going to tell you? Drill, drill, baby, drill. Oh gosh, this was a really bad pun. I apologize. Of course, this has nothing to do with Trump's drill, baby, drill. Completely different topic. Forget about what I just said. So you walk into a dojo and you want to learn jiu-jitsu. They're going to teach you techniques, but then they're going to tell you go and drill. Drilling means just exercise that arm bar 1,000 times, 100,000 times. The 10,000 hour idea by Malcolm Gladwell. All of these things go in the same direction, which you could argue skill acquisition, or you could just say memorize, 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 memorize action chunks. So then the question, of course, is what's the point, right? Mac, Schwager, what are you telling us here? Or why is this a bad thing? I mean, he's a very nice person, by the way, in terms of just very approachable, humble. So he's not saying, look, I'm bashing these models. By no means. I'm just saying this is what it is. And I think it's incredibly important insight, because it opens up the next question, which is, okay, what is the alternative? So if you're not happy, with memorization, so what do you want? Or what does generalization actually mean, right? What is that? Now he has a definition of generalization. He has a way to, through sparse autoencoding, it's a certain technique to go into the guts of a model and see how tokens assemble relative to tasks. And when he does that, he can kind of answer the question, is this token only triggered at task X, or can this token also be used for task Y and Z, right? So that's kind of generality in a very broad, crude way. If I have a certain token, let's call it token 17, can token 17 be applied to action chunk X, Y, and Z, or just X? And what he realizes is that like a 90% of tokens only apply to one action chunk. And that's what concludes, or that's what draws him to, that's what triggers the conclusion that memorization is the game. Now, having said that, we are in a regime now where we want generality. We want a humanoid robot that can work on a factory floor. Actually, what we want is a humanoid robot that can pursue goals. The definition of intelligence is the computational part of pursuing goals, something like that, by John McCarthy. So we want this thing to be able to pursue goals. Now, pursuing a goal, by definition, requires some sort of generality. You can't memorize everything because you don't know what the goal will look like, and you also don't know what the environment will be in which you're trying to pursue the goal. Clean my apartment with a toddler is a different problem than clean my apartment without a toddler, and so forth, right? So then what the bitter lesson is saying, okay, fine, look, just train this thing on many, 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 many data points with large, large models. So function approximate as much as you can. And what Schwager would say is, okay, just memorize. Memorize a situation where the toddler is in the apartment. Schwager, for example, also talks about context, right? Put this thing on the left side of the bin, and the thing learns to put it on the left side of the bin, but if the bin is somewhere else, it doesn't understand what left side anymore means, because maybe during the training process, it never understood what left side even means. It used other waypoints to understand. Therefore, it's not general. So, meaning the context also. Like say, I have my apartment, clean my apartment, it cleans it. Now I do a 360 degree, I turn it upside down, for example, and the thing has no clue what to do. Versus a human might be able to clean an apartment even if it's upside down, let's say in zero gravity, things like that, right? So the question then, again, the bitter lesson would say, okay, fine, find a way to generate all this data. And that's what world model technology is trying to achieve, because obviously we can't have all this data generated in the real world, but what we can do is, number one, bootstrap these models, and number two, use generative AI to generate scenarios, billions and billions of scenarios, kind of similar to agentic software development right now as we speak, which is kind of doing the same thing. Cursor and competitors are just running tens of thousands, hundreds of thousands of agents through RL-driven optimizations as far as software development is concerned, and they come up with the best solution, and then they use that to reinforce the next epoch, and therefore they're getting better and better at developing software. In other words, they don't really have fundamental deep understanding of computer science. They just iterate against memorized evals and just keep going. So so that would be my first point, my first comment about Max Schwager's work. I think the second point I want to make here now, or the second question I want to pose is, all right, what do we do now? How do we get more generality? What does it actually mean? So if we want to have tokens that are applicable to more than one action chunk, well, then we have to train our model to do that, right? So we have to find ways to train models so they can apply different same to so you kind of have to maybe discriminate in the optimization process. I mean, this is just me thinking out loud now, but you have to maybe penalize tokens that are only applicable to one and force the model to have two or more, like something like that, right? That would be because you get what you measure, right? You get what you optimize for. It's not just in AI. Everything in life is like that. You get what you optimize for. You get what you measure. If you don't, I mean, if you train a model based on memorizing, then it's going to memorize, and that's kind of what we're doing now. And this is, as far as I'm concerned, also the main critique that Richard Sutton came up with. Or said or concluded when he introduced the oak model, the oak architecture, right? He said he came from a different perspective. He came from the concept of plasticity. He said these things are basically not plastic, they don't adapt. And I think we're all talking about the same thing here, which is lack of plasticity just means lack of generality. It means the model can do one thing really well, but it's not able to generalize and do other things well, or in Sutton's word, it's not able to continuously learn. So the question then is, how can we architect models that continuously learn? And then we're really in the sort of Richard Sutton territory. Tom Silver from Princeton also talks about this from a different angle. I think we don't want to go too far here. We just want to say that we need some sort of maybe tool use, but fundamentally, what our AI systems need to understand is how to pursue a goal and what tasks they need. Once they understand that, and then they also have the ability to maybe generate their own learning protocol to learn a task. So let's say if my robot cleans my apartment and there's a toddler in the apartment, it learns that it has to learn a new task, which is avoid the toddler and maybe learn about the toddler, run different queries, AI queries, things like that, to understand what a toddler is, use the semantics, and then make decisions accordingly. So that's on the model side. Again, I think the big takeaway here is if we want to have general tokens, we need to train models to get general tokens. And we can also have tokens which are trained to generate solutions or find ways to pursue goals, understand what tasks are necessary to pursue goals. Now, the last thing I want to say in this context is we should also look at the full stack here. Full stack is, again, the cake, the NVIDIA cake with the 5 layers of AI, energy, chips, models, cloud, model providers, and intelligence and flexibility can be built in on all these layers, right? And fundamentally, the most interesting layer, of course, is the biological layer, is the company which actually provides the AI. For example, Tesla has a system built around its FSD that is flexible enough and has the ability to generate tokens when needed. For example, they have shadow mode. For example, they have they generate their own data, synthetic data, to solve difficult edge cases. So there's a lot of like cross-stack solutions are being produced to solve the more general problem. In the case of FSD, it's the full self-driving. And I think I want to get back also to NVIDIA, like extreme co-design is not just on the chip level, it's on the whole stack, on that whole cake layer. And I think that's how we should be thinking going forward as far as investors and as far as also AI predictors, or if we want to see where AI is going, and if we want to take Max Schwager's work seriously and also answer the question, how can we get more general AI? The answer is look at it from a full stack perspective and bring in flexibility wherever it's most optimal. Thank you.